Hey there, today we're going to talk about transformations of functions. A very important topic. You need it so badly to know how to do transformations. I can't even express it with words. Alrighty, in order to do this, there are certain things that we are going to need to have background knowledge of. That's the domain, the range, intervals where it's increasing, decreasing, and symmetry. And the reason why we need to know these type of things, pretty much the background that you really need is, do you know what the parent function looks like? So for instance, we're going to talk about vertical shifts, but for instance, if you have y equals x squared, do you know what that already looks like without having to plug in points? And if you need to plug in points, that is fine as well. But let's go ahead and do vertical shifts. If the slide I just showed you, you didn't need to write that down because we're gonna get there right now. Vertical shifts. The first shifts that we're gonna talk about is vertical. That's a type of transformation, and the vertical shifts, just like the way it sounds, would shift the graph up or down. You will shift the graph up if you have a c attached to your parent function. So if your function is x squared, x cubed, natural log of x, log of x, if you have e to the x power, these are parent functions. But if you have like a 5 lingering on the outside, so like x squared plus 5, or e to the x plus 5, where 5 is on like by itself, then it would shift your graph upwards 5 units, or in this case c units. If you have a minus c, we're shifting downwards. So over here, this is f of x. It could be any type of function, but if you have f of x plus 5, then we're moving this function upwards. If you have f of x minus 5, we move downwards 5. In this case c. We're just saying c is some kind of constant that is positive. So let's do an example right here. I know what the parent function looks like. The parent function looks like this for x squared. The parent function of any parabola looks like this. When you have x squared plus 4, are we going to move up or are we going to move down? What do you think? We move up, so that's why it's going to look like this. We're going to have a parabola, but because we had that plus 4, we're moving up 4. So 1, 2, 3, 4, and then we're going to start a parabola again. It needs to be identical too, so this needs to look the exact same way. And I'm going to do an example from scratch where I actually create imaginary axes. You'll see. You're going to like it. Now over here I want to spend a little bit extra time, because with horizontal shifts we are breaking all the laws. We are at a riot where we break windows and all kinds of stuff, because we are going to do stuff that's really contradictory to what we saw before. Over here we have y equals f of, and then inside we have x plus c. Whenever you have the plus c or minus c within the function, like in this case, then we're going to move to sideways, and you'll see an example of how you can identify whether the number is inside or outside. Because most of you are probably thinking, okay, you're telling me that that's a horizontal shift, but is it really that obvious? It is, and I'll show you. But if you have a x plus c, you would want to say, okay, plus c, move to the right, because that's where the positives are. Because when we had a plus c before, on the vertical shifts, we moved upwards. That's where the positive y's are, right? Well, with this one, we do the opposite. So where there's a x plus c, you would think you go to the right. So you would think that over here, you are here, right? This is your function right here. We would move to the right. But we actually do the opposite. We move to the left. Over here, the graph looks like y equals f of x minus c. And over here you would think we go to the left because of that minus c. We actually move to the right. So unlike the vertical shifts where we actually go upwards if it's positive c and downwards when it's negative c, for the horizontal shifts we do the exact opposite. If it's plus c, to the left. If it's minus c, to the right. So here's an example. And I don't like the way that the PowerPoint is set up, so I'm just going to do it for you guys. I know that you guys prefer the PowerPoint and everything, but give Mr. S a chance, huh? Would you? So we have h of x equal x plus 1, and that was squared minus 3. Now over here I want to explain to you what kind of shifts I see. This number right here, this is a vertical shift. And the reason why this is a vertical shift is because the -3 is happening outside of the function. So think of it as the parent function for this guy. Let's go ahead and call it f of x equals x squared. That's the parent function. And the reason why I call it the parent function, the only number I see is the exponent. All the other numbers are removed. This guy moves this function down 3 because that's vertical shift. That's outside the parentheses, right? It's outside. It's like attached right there. And then we have a number within the parenthesis. And when we have a number within the parenthesis, that's a horizontal shift. Also, the shifts, the horizontal vertical shift happens when it's not attached to the x. It's right next to the x. So it's x plus 1, right? It's not x times 3 or something like that. So let's graph this guy. First things first, graph the parent function. Just so you can prove to yourselves, yes, Mr. S, I know how to graph this. You know, I'm ready for this new stuff. But then I look at you, I'm like, are you ready, huh? You think you're ready? Well, I do not think so. Because I just gave you a test the other day, and look how you did. Alrighty, and then we move the function down 3. So 1, 2, 3. And I like doing that. I like creating these imaginary x and y axes. I see a lot of imaginary things, and this one is, you're gonna have to share this trait with me. So this is -3, we move down 3. Over here we have x plus 1. Are we moving to the right or to the left? If you are leaning towards the left, you're absolutely right. We do the opposite. Like at -1, I don't like the way I just used like. At -1, we do a imaginary vertical axis. Bam. So now we have an imaginary x-axis, imaginary vertical axis. Now we can draw the parent function again. And let me use a different color for this one. Bam. There we go. I think I nailed it too. Oh wow. That was terrible. And just after I praised myself, I was doing so good. And let's go up. There we go. Here's a function. So pretty much that's what the parent function looked like. And now we drew the function again, but we drew it down 3 and to the left 1. This is a vertical shift outside the parenthesis, horizontal shift inside the parenthesis. Down, left. Alrighty, let's move on. And then over here they have it in a mixed up order. Don't worry about it. Pretty much you can see how the black function looks just like the red function, except it was moved to the left.